Hey guys, today we're going to talk about graphing logarithmic functions. Okay, so we are going to make a t-chart and graph based on that t-chart. Now, in order to make that t-chart, I find it easiest to put this in exponent form. It's not the only way this can be done, but I think that's the easiest way to find our points. So this is log base 10 since there's no base written, so it's common log. And I'm going to put both sides in base 10 to cancel out that logarithm. So I get 10 to the y equals x. Now the easiest way to make this chart is to start with the y. Okay, so we're going to start by plugging in y values. So I'm going to put in a 0. 10 to the 0 power. Anything to the 0 power is 1. So I get my first point at 1, 0. Okay, for my second point, I'll put in a 1 for y. 10 to the first power is 10. So we get a second point at 10, 1. Then 10 to the second power. 10 to the second power is 100. So that means we would have to go all the way out to 100 before we reach a height of 2. So on this graph, we'll never see it reach a height of 2. Okay, now we're not going to go any farther out than 102. So let's go to negative 1. 10 to the negative 1 power. So remember, anything to a negative power is 1 over that number. So it's 1 over 10 to the first power. So that's 1/10. 10 to the negative 2 power is 1 over 10 squared. So that's 1 over 100. So we've got 1/10. 1, then we've got 1/100th, and then negative 2. I think I said 1 here, but that's negative 1. So what's going to happen is no matter how far negative we go, we're never going to reach 0. We're going to get infinitely close, but we'll never reach it, which means that on this part of the graph, it's just going to hug that y-axis. It'll never technically touch it, but it'll get infinitely close. It'll never curl back into the right either. It'll just hug that y-axis. On the right side, we're going to go out to that point at 10, 1, and then we're never going to touch a height of 2 until we get all the way out to 100, but we're not going to go that far. So there's our first graph. For our second graph, we're going to put it in exponent form again. We'll start first by getting this 1 over to the other side, so it becomes y minus 1 equals log, that's base 10. X minus 2. Okay, so we've got common log again, which means we're going to do base 10 on both sides in order to cancel out that logarithm. So we've got 10 to the y minus 1 power equals x minus 2. And then we'll move that minus 2 to the other side. 10 to the y minus 1 plus 2 equals x. So we'll make our t-chart. And once again, we'll start with y. So let's just start with the same y values and see what happens. So we'll put in a 0. So that's 10 to the 0 minus 1. So that's negative 1 plus 2. And that's 2.1. So x is 2.1. So our first point is 2.1. 0, so just a little bit past 2, and then up 0. Okay, our next point, 1, so that's 10 to the 1 minus 1, which is 10 to the 0, which is 1, plus 2 is 3. So we get a point 3, 1. Okay, and we'll put in a 2. 2 minus 1 is 1, so 10 to the first power, that's 10, plus 2 is 12. So we get the point 12, 2. Okay, if we put in a 3. Okay, then we've got 3 minus 1. So that's 10 to the second power, which is 100, plus 2 is 102. So we've got to go all the way out to 102 on the x-axis before we can reach 3. So we're not going to go that far. So let's go back the other direction. We'll put in a negative 1. Okay, so negative 1 minus 1 is negative 2. So let's type that in the calculator. 10 to the negative 2 power plus 2, and we get 2.01. Okay, so we had 2.10, and then 2.01, negative 1. So what's happening is we're going to get closer and closer to this x value of 2, just like we got closer and closer to an x value of 0 up here. So this time we're going to hug x equals 2. It'll never actually touch it. It'll get infinitely close. So on the graph, it's just going to be hugging that x value, and then it will go off to the right, hit our point there at 12.2, and then slowly rise up to an x value of 102 and a y value of 3. Now notice these two graphs are very similar, but what actually happened, what the difference is this one is shifted 2 units to the right and 1 unit up. Notice we had a point of 1, 0. If I look at that point 1, 0 and then go 2 to the right and up 1, I've got my starting point here. So this minus 2 inside the logarithm told me go 2 to the right, and this plus 1 told me go up 2. So now we're going to talk about shifting graphs. Okay, when we have something added or subtracted inside of a function that tells us to move left or right opposite the sign. So add or subtract inside the function goes left or right opposite the sign. If we add or subtract outside the function, we go up or down with the sign. Okay, so this minus 2 inside the function told us to go 2 to the right. This plus 1 outside told us to go up 1. Okay, so this function right here, if I was to graph it, would just be shifted left 2. This one would be up 3. Inside the function, we go opposite the sign, left 2. Outside the function, up or down with the sign, up 3. So a minus 4 inside the function tells us to go right 4, and a minus 5 outside the function tells us to go down 5. Okay, now we are going to graph a natural log function. Okay, and we're going to do it the same way as before. We're going to put it into exponent form. Remember, natural log is log base e. So we're going to do base e on both sides. Okay, so when I do that base e, that cancels out the natural log or the log base e. So I get e to the y equals x. And I'll start my t-chart with a y value of 0. E to the 0, anything to the 0 is 1. So I have the point 1, 0. E to the first power. Okay, remember e is a number, not a variable. So e to the first power is 2.72. Okay, so over 2.72 up 1, so somewhere around there. Okay, next we'll put in a 2, e to the second power. 7.39. So over 7.39 up to somewhere around there. Okay, e to the third power. 20.09. Okay, so I've got to go all the way to 20.09 before I can go up 3, and we're not going to be able to go that far. So let's go to negative 1. E to the negative 1 power. 0.37. So 0.37, -1, so somewhere around there. Okay, then we'll do the -2 power. E to the -2 power, 0.14. So 0.14, -2, and you can see this is getting closer to an x value of 0, so we're going to hug that x-axis again. It will never touch it, but it will get infinitely close. So that's what our graph should look like. Okay, shifting natural logs is the same as shifting logs or any other function. Adding 2 inside of a function is left 2. Adding 3 outside the function is up 3. Subtracting 4 inside, right 4. Subtracting 5 outside, down 5.